Hello, and welcome to this video on convergence of a series. We have the series sum from 1 to infinity of 1 over n cubed, and we want to learn if this series converges or not. To work with this problem, we're going to use something called the integral test. So let's review what the integral test is when we use it. For now, let's just notice that the nth term of this series is 1 over n cubed. And we can tell that as n goes to infinity, the nth term goes to 0 because when n is huge, 1 over n cubed is really small. There is a chance that this series converges. Now, if we look at the nth term of the series, this term can be matched with a function evaluated at n, where the function is given by 1 over x cubed. If we substitute n into f, we get 1 over n cubed. And this function f is a function that is continuous because when we graph this function, and it continues from 1 to infinity, I want to say from 1 to infinity without including the 0. So f is continuous. And it's actually decreasing when we look at the graph of 1 over x cubed. From 1 to infinity, we get something decreasing. It's going down. And it's a graph that is positive. As long as we keep to x positive. So the nth term of the series corresponds to f of n, where f is 1 over x cubed. And the integral test tells us that convergence of the series we have is equivalent to convergence of the corresponding improper integral. So we have that this series that we were given, 1 over n cubed, converges if and only if an improper integral, the integral from 1 to infinity of the function, converges. Meaning we get a number out of that integral from 1 to infinity. And when we look at that integral, we realize that that integral is going to converge. Let's look at that integral. When we have the integral from 1 to infinity of 1 over x cubed, this integral converges because we have the limit as b goes to infinity of the integral from 1 to b of 1 over x cubed, and that 1 over x cubed can be written as x to the negative 3. When we integrate x to the negative 3, we get x to the negative 2 divided by negative 2. We want to evaluate this antiderivative at b and at 1. So we find the limit as b goes to infinity of b to the negative 2 over negative 2 minus 1 to the negative 2 over negative 2. We can rewrite this as 1 over negative 2, all that times the limit as b goes to infinity of b to the negative 2 minus, and any power of 1 is 1, minus 1/2 of the limit as b goes to infinity of 1 over b squared minus 1. And when b is huge, 1 over b squared is really small because b squared is huge and we're dividing a fixed number by something that is getting increasingly large. So here we have -1/2 multiplied by -1, or same thing, 1/2. So since this integral converges, we can say that the summation from 1 to infinity of numbers that look like 1 over n cubed gives us a fixed number. We don't know what that fixed number is, but it will give us a fixed number. All right, so to solve this problem, let's see what we did. First, we checked that the nth term goes to 0 to see that there is hope in checking that the series converges. Then we matched the nth term with f of n, where f is continuous, decreasing, and positive. And then we used the integral test to say that convergence of the series is equivalent to convergence of an integral. Then we found that the integral was finite, the integral converged to 1/2. So we said, okay, because the integral converged, then the series converges because of the integral test. All right, that's it for this video. Thank you for watching.